right, so today we are starting Chapter 5. And 5.1 today is rate of change. Which is also called slope. Rate of change is how quickly something changes over time. Which means we have to compare how much you go up or down to how much you go to the right over time, right? Because time is always the x-axis, or it moves forward always, right? So first thing I want to talk about before we get into that is some of the other words for rate of change, right? We have rate of change, we have slope, we also have, and I know you guys have heard this, rise over run. Sometimes we call the exact same thing the change in y over the change in x. Very good. Does anybody know what letter we use when we represent slope? It's actually the letter M. You knew that, didn't you? Yes, exactly. M represents the slope. And the last thing, we do have an equation, which also should sound familiar to you. y2 minus y1 over x2 minus x1. That should also sound familiar. Okay. So all those things mean the exact same thing. They all find the exact same thing. We just find them in different ways. So first place I want to start talking about it is finding rate of change from a table. So find rate of change from a table. When you are doing it from a table, whoa, that's not very straight, sorry. You have to do the loops on both sides. All right, so if on this side I have, for example, 1, 3, 5, and 7. And on this side, let's say I have 4, 9, 14, and 19. To find the rate on the table, you have to do loops on both sides and divide the y over x. So we're going to start on the x side and go 3 minus 1 is 2. 5 minus 3 is 2. And 7 minus 5 is 2. Then we go to our y's. Same thing we've been doing forever. 9 minus 4 is 5. 14 minus 9 is 5. 19 minus 14 is 5. So to find your rate of change, you take your y, which is 5, over your x, which is 2. That's it. So this really fits into that equation we just said. The top is our y. This is my y2 minus my y1. The bottom is my x's. My x2 minus my x1. Same exact thing, right? So it all fits together. So your first couple problems in your homework are just like this. So example number 1. This is 8 and 10. Find the rate of change and, that's an and sign, explain And let's say on this side, I have hamburgers. Oops. And on this side, let's go with cost. And let's go with 2 is $2.50. 4 is $5. 6 is $7.50. And 8 is $10. All right, so again, we're going to do our loops. 4 minus 2 is 2. And again, it should be the same all the way down, right? My x2 minus my x1. On this side, 5 minus 250 is 250. So now I take my y over my x, and since there's a decimal in it, I need to simplify. 250 divided by 2 . 1.25. All right. So now we found what the rate of change was. Yes. You absolutely have to right now? Go ahead. Okay. So now that we found the rate of change, the second part says explain what it means. So remember that this is technically y over 1, right? So the cost is $1.25 over or per 1 hamburger. So you're just explaining what it means. And take the labels that are up here to help you explain it, okay? All right. Example number 2. Let's do it this way, actually. Hold on. 1 minute. We're going to take a quick time out. What's that look? Huh? What do you mean you hate these? Well, Marco, that would have been my fault because I gave it to him. Not taking notes? Do you want them?
Sure.
Okay. There you go. All right. Okay, what I'd like you to do is go ahead and put example number 2 on your paper, and then put your sticky in there and make sure only one sticky, make sure that it's Y to the sky. You have it in the right direction. Yep. All right, so everybody should have Y to the sky in their example number 2. I would like you to put a dot on your graph at, how about 2, -3. Put a dot right there. 2, -3. Put a dot at 1, 1. Oh, did I say 2, -3? I meant -2, -3. That's my bad. I'm sorry. I thought I said -2. My bad. Okay. So I want you to find the slope between the points. when we do this, you always start at the left point. And then we count, rise, and then we count, whoops, run. All right? So on this one, we're going to start at the leftmost point, which is this one at -2, -3. We're going to start by counting rise. 1, 2, 3, 4. Now it's even with that one, so I have a 4 on top. And then I always run to the right. 1, 2, 3. Okay? Same thing, example number 3, you're going to put in another sticky. Whoops. Sorry. Thought I had turned that down today. It's weird. All right. All right, so again, example number 3. Again, put your sticky wide to the sky in here. All right, this time I want you to put a dot at -3, 5. 1, 2, 3, 4, 5. So you should be in the second quadrant, -3, 5. I want you to put your second dot at, how about 2, 2, 2. Find the slope. All right, so this is exactly what you are doing for 12 through 16. It's going to give you 2 points. It's also going to connect the line in between the two in your book. But you're still going from point to point. So you start at the leftmost point, which is this one. Now, if we're counting down, what do you think that's going to say about our number? It's going to be a negative, right? So we're going to go 1, 2, 3. So going down is -3. Over. And now we always go to the right. 1, 2, 3, 4, 5. Are we okay? This is easy. We're good? Okay. Example number 4. Example number 4. This is what you are doing for 18 through 22. Find the slope. But this time it's between 2 points. Okay? So if I have the point, let's say 5, -3, and let's go 2, 9. We have to use that formula that we had at the very end of our list, which is y2 minus y1 over x2 minus x1. I'm going to remind you that this is my x1, y1, and this is my x2, y2. So I'm going to start with my y2, which is 9, minus my y1, which is -3, over x2. What number is x2? 2, good. Minus my x1, which is 5. All right. On the top, I have 9 minus the negative 3, so I have a sandwich, don't I? So 9 plus 3 is 12. On the bottom, I have 2 minus 5, which is negative 3. And if that reduces, you need to reduce it. So 12 divided by negative 3 is negative 4. Let's try another one. Underneath that same thing. Move it up a little bit. Let's go with the points. How about negative 3, 1, and 5, 7. All right, so again, this is my x1, y1. This is my x2, y2. All right, we're going to put it into the equation or the formula we have here. So y2 is 7 minus y1, which is 1, over x2, which is 5, minus x1, which is negative 3. On the top, I have 7 minus 1. Good. On the bottom, 5 minus the negative 3? 8. Excellent. Can I reduce that? To what? 3 over 4. Perfect. All right, so do we have any question how to put it into that formula or that equation? No? Okay. So then let's go to example number 5. Now I'm going to skip a few problems for a second. We're going to jump over to 26 through 32 real quick. And then I'll come back to those other couple. All right. 26 through 32. Find the rate of change, which just means slope. And let's say the snow is 3 inches deep on day 1 and 7 inches on day 4. All right, so first of all, we actually have 2 points up there. We have the point for the first one, which is 3 inches deep on day 1. Now remember, out of inches, the 3 inches of snow, and day 1, which one is actually our x value? Which one is time? Which one is independent? The day. So our first point is actually 1 and 3. Our second point, again, remember that x is always the time, that's 4 and 7. So this is my x1, y1. This is my x2, y2. Right? This is point 1. This is point 2. So now we're going to put it into that same exact equation. y2 minus y1 over x2 minus x1. y2 is 7 minus y1, which is 3, over x2, which is 4, minus x1, which is 1. 7 minus 3 is 4. 4 minus 1 is 3. So same exact thing, right? It's just that it's in word form instead of as a point. You got to put it in a point. Okay? Any questions there? All right, then the last thing I need to talk about is the special slopes. I want you to imagine if I have a line that's going horizontally, okay? And I put a car. You can't make fun of my car. Oof. I put a car on that line. How fast is that car moving? I mean, if it's sitting on that line, is it going to move either way? No. So the speed or the rate of change of this is 0. So anytime you have a line that's horizontally, it's 0. Okay? That's your rate of change because it's not going to move. Whereas if I had a line that was going this way, my car would have to climb or speed up to get up the hill, right? Let's say I have a line that goes up and down, straight up and down. And my car was on the side of it. What do you think is going to happen to that car?
Is the car a toy car?
Even if it's a... Yeah. Okay? So what happens to that car if I have it on the side and I let go? It crashes. Anytime you have a line that's up and down, we call this undefined. Okay? So if you have a vertical line, your slope is undefined. It can't exist because it's going to crash to the ground. All right? So if I have 2 points, let's say I have the point 3, 5, and 7, 5. And I want to find the slope. So again, this is my x1, y1. This is my x2, y2. y2 minus y1 over x2 minus x1. 5 minus 5 is 0. 7 minus 3 is 4. 0 divided by 4 is 0. What kind of line do you think I have? Nope. If I have a slope of 0, it's a what kind of line? Horizontal. Thank you. Okay? So if I get a slope of 0, I have a horizontal line. Let's say I have 2, negative 7, and 2, 9. So again, oops, this is my x1, y1, my x2, y2. All right, y2 minus y1 over x2 minus x1. 9 minus a negative 7 is 16. 2 minus 2 is 0. Can you take in your calculator and go 16 divided by 0? Try it. Tell me what it says. It says error, doesn't it? So this is undefined. And so what kind of line would I have here? A vertical line. Okay? So now the last couple problems we need to talk about, and then I'll let you guys start your homework. So I think I'm on example 6. Name the slope. And let's say on your graph, they give you a line that looks like this. What is my slope? 0. Perfect. What if they give you a line in the picture that looks like this? Yep. That's all you have to do. Okay? There's no other math to it or anything. You see the picture, you see it's horizontal, you say 0. You see it's vertical, you say undefined. All right? Any questions? Shall we get started? Today you are doing 8 to 32 even on page 298 to 299.